Hi, everyone. I'm just going to start off by letting everybody know I'm a little bit shy, so sometimes I get a little bit nervous, and it's been a long time since I've been in front of the public. So bear with me if my pace changes a little bit. I talk too fast or I stutter a little bit, but we'll get through it. Okay, so let's start this off. So I'm going to be I'm going to be using mainly a slide presentation today. I do normally like to get hands-on and actually show and get interactive because that's what we love about the microbit, right? But simply because of the subject matter that and what we're exploring today, we have some limitations because what we're going to be doing today, when you do it online, it requires that you use your microphone or your video camera. And since we're in conference, there would be a conflict. So what we're going to see is slides of it, but I've, as much as possible, provided QR codes so that later on you can go off and try this on your own. Everything that you're going to see is available to the public. And I think pretty much all of it is open source, so you'll be able to go into it and look into it. All right, so a little bit about myself. My name is Phil Greene. I'm a web service manager, a developer, an occasional instructor, and always playing and tinkering with tech. And I just love microbits. Some of you might have seen some of my work before. I got one of them running in the background, and it's always very exciting. I work for a company called Kids Code Jeunesse, and we're a bilingual charity determined to give every Canadian child access to digital skills education with a focus on girls and underserved communities. Fun fact about myself, that is my first personal computer, the Timex Sinclair 1000. Pretty old, took me a whole summer to save up for it. And when I started playing with the microbit, I got that same feeling when I first got this Timex Sinclair way back then. The same sort of excitement. So it was really, an exciting journey to go from that and then find myself feeling the same way that I felt when I was young and a kid, and just first getting my hands on this personal computer. So a little fun fact there. All right, so let's look at Teachable Machine. So what is Teachable Machine before we get started? So Teachable Machine is a web app, and it's developed by Google, and it's built on top of a TensorFlow. And TensorFlow is basically a library to explore machine learning and artificial intelligence. And what they did with Teachable Machine is they decided to wrap this in an easy, fun, accessible way. It was the first version that came out, which is what we're looking at here, was pretty simplistic and was mainly focused on recognizing images. So what you would do is you would train the system, you're training a model to recognize different types of images. And then it would predict what it's looking at, and you would continue training in order to get this better. Now, what's really fun about TensorFlow and Teachable Machines is that it really makes this accessible in the classroom for various different reasons. One is that it uses a type of technology around training and deep learning that allows us to train very rapidly. Training a model from scratch can take a very, very long time, in the order of days. Not something real, that's realistic to do in the classroom, especially if you're doing a short session and you want to explore this. So this is one of the advantages. The other advantage is that it runs locally. So when you're training it with images, these images are not being sent to a server or to the cloud, so to speak. So everything is done locally. Your model is local. So it does address this issue with kids that we're all, always concerned about, which is security and privacy. It's also open source. So these are wonderful things. So when it first came out, we saw this, and we know that AI is a real big hot topic. And we wanted to see if there was a way that we can bring AI into the classroom. Now, Kids Code Jeunesse focuses on young kids. We're mainly elementary, anywhere from grade 3 to grade 9. And we're starting to explore into the high school, but we're dealing with mostly young kids. And we thought this was a good starting point. So we explored it a little bit. And for the most part, it was interesting, but we weren't able to get to the more deeper conversations around AI. It just wasn't simply setting the stage properly for us, or it wasn't succeeding at setting the stage so that the kids can make that leap to the more deeper discussions that we can have around AI. Things like, ethical use of AI or bias and all these sort of things. And we were pondering about this. We were trying to figure out like why this might be so and how can we get around it. And what we came to realize was that, well, one of the reasons why our microbits work so well as a tool for teaching is because when we have it in the classroom, it's this inanimate object at the start, and it isn't until the kid code it and get their code on it that it comes to life. And that really gives a sense of ownership to our kids. When we're coding on a computer and you're on your laptop and you're doing things, well, it's not too certain how much the computer is doing for you, how much of it was really a result of your coding. But with the microbit, it's very clear. Once you get your code onto that microbit, and it's strange because you'll see kids look at a simple animation in a simulator and they're like, oh, okay. But as soon as they get it on the microbit, there's this yelp of joy. And I think that really gives them a sense that it's their project now. So that's how this came about, this project. We said, well, how can we do this? And we thought, well, what if we can connect teachable machines to the microbit? And so that's what we attempted to do. I did a little bit of research, found a few libraries to help us, and built a web app that would allow us to connect the teachable machine to the microbit. Now, there were a few limitations with this. One of the limitations was the first version of Teachable Machine would only allow you to actually create a couple of classes. That means you could only create a couple of categories for what you were training it for. So if you wanted to train it, say, on the alphabet, you could only do, I think it's 3 was the limit in the first one. So you could only do A, B, C. So there are some limitations there. There was also some limitations around the original version didn't allow you to save your model. So once you left the website and returned, your model was lost. So there is a few limitations, but we did have some success. One of the interesting projects we thought about was, we can teach it to recognize images, but can we come up with an interesting project where, around tech for good? And we thought, well, sign language would be a real fun one. And it'd be really, something really suitable for machine learning around visuals. So we tried it out and it was pretty successful. We were able to teach it, and again, keeping in mind the limitation, we were able to teach it a few letters of the alphabet and it would recognize it. And then in connecting it to the microbit, we got the microbit to display the letter that it was seeing as far as sign language. Now, this was really interesting because right away we can kind of see the potential here. You could imagine that, and TensorFlow has a TensorFlow Lite that can work on mobile. You can imagine that you have this on your mobile. And if you ever get in a situation where you have to communicate with somebody who only knows or only can communicate using sign language, you can use your mobile asking permission and explaining what it does, and be able to have the sign language translated for you. So already the potential was there. But again, there's these limitations. A couple of other fun projects that we did around it. We also had our microbit learn to read sheet music. So we would cut these out into cards and we would train the teachable machine to recognize these as certain notes. And then we got our microbit to play those notes. So that was a lot of fun. And from there, we've got some pretty, interesting ideas. Some people realize, okay, so if it can read sheet music and play notes, why can't it look at me and look at my hand positions and play notes, so that my hand now becomes an instrument? And sure enough, it worked. But again, we were a little bit frustrated, and our audience was a little bit frustrated because of some of these limitations with the first iteration of Teachable Machine. Well, not long after, maybe about a year and a half after, they came out with a new version with a whole bunch of new features. And this brought me back to the project. The new Teachable Machine now allowed for learning about poses, images, and sound. So this really opened up things for us. Also, you'll probably notice here on the slide, it's a little bit small, but the ability to, to add new classes or new categories or groups. So, and unlimited. So now we could do the full alphabet if we wanted to, or we could do a very, very, very long range of musical notes and stuff. So it really started opening things up. More than that, they added the feature that we've been waiting for and hoping for, the ability to save your model. And they give you a whole bunch of options. You can save your model locally, or you can save a shared link to the cloud. And then pass that link to anybody else, and they can load up your model. So that really made it worthwhile to go back and look at what we were doing with our application. Whoop. One sec. Right. So go back and revisit our application. And we went back and we said, okay, let's add the ability to choose between using video trained model versus a sound audio trained model to be used and connected with our microbit. We also added the ability to load a saved model from Teachable Machine. So back on that previous screen where we saw the ability to save a model to the cloud. So we're doing the shared link is what we're doing. Once you create that share link, you just pop it in here after selecting what mode you want to use. So we did that. And we got back to here where we were able to now connect our trained models that were saved in Teachable Machine to our microbit. You'll see, and it's worth pointing out, if you do happen to go on the site, there are some instructions as well. So if you want to use it, these instructions are found on the site. And please feel free to use it. Please feel free to give feedback. Just keep in mind, it is an alpha. It's something that, my code is really messy too, but it is something that if we find that there's enough interest and it's useful, I think we'll continue to pursue it and work on it. All right. So now, not only are we able to get video trained models and audio trained models connected with our microbit, we are now at the point where we're starting to think about the code on our microbit, and this is the great part. So the code for the microbit for understanding and doing things with the results of these trained models is very straightforward. What we're doing is we're simply connecting a microbit to our USB to the web page. We're pairing it in the same way that we pair a microbit on MakeCode. And all we're doing is we're testing for the predictions that are coming back. So when Teachable Machine thinks it sees the letter A in sign language, it's simply going to pass the label, its prediction, to the microbit over to USB. So this is why what we're going to see here is we're going to see a block that maybe we don't see very often, but it works very similar to any other event block. It's called serial on data receive. And it's the same thing as a radio block on, radio on receive string or radio on receive number. It's just listening for a simple event. That's all that's really special about this connection to this teachable machine to microbit bridge. Once we listen for that, what we're simply doing is we're just using our conditional blocks, our logic blocks. And most of us are familiar with that. It's simply where we're testing the value and telling the microbit to do something based on the value. So in this case, we had a sound model trained to recognize the word up, down, left, right. And kind of think about it as the beginning of, being able to give your robot instructions or something like that. And so we simply were listening for teachable machine model when it recognizes those voice commands. And if it heard up, it would show an up arrow, down, it would be a down arrow, so on and so forth. Okay, so things were getting really interesting, and we wanted to see where this could go. Well, the microbit, what's really wonderful about the microbit, and I was talking a little bit about it earlier, the fact that, this is an external device. It's inanimate until the coder, our young kids, get their code on it, and then it comes to life. So it gives them this sense of ownership, but we all know the microbit does a lot more. It really also allows us to engage with our environment. And this is really, really important, all the more so these days, because, a lot of us are at home. A lot of us are spending a lot of time in front of the computer. So the microbit as a teaching tool is a fantastic way to teach about critical thinking and computational thinking, and coding, obviously, but at the same time, to get our kids up and away from the computer. There are projects that we can make, for example, sensing the light, sensing the temperature. And this is all wonderful because then we get them to explore and rediscover the physical environment around them. So naturally, we wanted to keep playing on this. So our next step we did is, well, why not have it connect to a speaker to play notes? Well, we mentioned that before. So if it saw a note or if it heard a word, it could play. We could tell it to play a song. We could have it play one of the musical songs in microbit by voice command. And you'll probably have a sense of where this is going. We could also connect it to lights. Well, why not a fan? And why not a bell? That you probably saw that bell behind me. We could do that as well. Why not? Or these. This is a micro vibrating motor, and this will come back later. We'll see why this is interesting, this particular one. But suddenly, we have a voice command for our microbit that operates all these devices. And what it's similar to is something like, Alexa's or Google Home. So we now have an opportunity to show our kids how these devices actually work and to explore some of the challenges there. Now, the sort of challenges that you get there are really interesting. And this is back to what I mentioned earlier, some of the deeper conversations that we would like to explore around AI. And what we realized is that if we can get the kids excited about their projects, if we can get the AI into their hands so that they're building their projects, getting excited about their project, that excitement will get them to that next level of learning. We've all been there before. We've all been, whether it's through hobbies or our own experiments or exploration, when we do something that we're excited about, then we actually get into a learning mode. We get hungry for more, to understand it more, to explore it, to experiment, curiosity, experimentation, and discovery, right? And this is what's happened. So at this point, now we find that the kids or we're discovering and exploring the idea that the kids are more ready to actually have deeper conversations around AI. Might they not discover when they train their system to interpret sign language that maybe it doesn't work well for all people who are doing the sign language? Does the size of our hand affect it? Does, having multiple hands, the color, the age, do these all play in it? And it's the same thing with voice. I'll train it for my voice, but will it work for my daughter's voice? And then they get to test it, and it becomes a fun thing to do, a fun experiment. And then and that has a natural lead into these deeper conversations around, built bias being built into AI systems. And we've heard a lot about that, or facial recognition and how facial recognition can fail. So this is a great way to explore it. And that's basically what we discovered. But similar to our first project, we wanted to have a project to use tech for good. Our first project, the visual project about interpreting sign language, we thought, well, what could we do now that we have, that Teachable Machine supports training models around sound recognition? Well, this is what we came up with. So what we did is we actually used 2 microbits here. We had one microbit which was connected to our computer that had the trained sound model loaded, and then was using this Teachable Machine to microbit bridge that we built. And what it was listening for were certain keywords. And we imagine this scenario where we have somebody who's hard of hearing and needs some assistance, or could use some assistance in their home environment, any environment. So what we did is we then connected a second microbit to a battery, so it was autonomous, it could move around, it was mobile, and we attached to it this small micro vibrating motor. And if you want to think of it, most of us have one. If you have a mobile phone and you set it on vibration mode, that's what it is. Now imagine you have that in your pocket, and now your Teachable Machine to microbit is listening for particular words or sounds. Maybe it's your name. If somebody says Phil and I'm not looking, so I don't hear it, our Teachable Machine to microbit recognizes it, sends a little radio signal to the mobile unit in my pocket, and it vibrates. And then I know, oh, wait, somebody might be calling my name. You could set different numbers of vibrations depending on the word. So you can have all sorts of sounds that it can recognize. So this was a really, really interesting project to start exploring, and that we're starting to build out. I think it really demonstrates how not only can, working with AI and microbits be a lot of fun and make us understand a lot of the stuff that we're seeing out there like Google Home and stuff, but it also empowers our kids to actually start prototyping their own solutions and ideas. So basically this becomes a prototype, a functional a prototype to validate these wonderful ideas and explore these ideas. It's really quite rewarding. Now, I just want to very quickly point out the tech stack that I used to build this bridge. So it's very simple. There's something called ML5. It's a library it's a JavaScript library that basically wraps Teachable Machine and makes it very easy to program. It's in JavaScript. The other one is we use dap.js. I believe it might actually be the same library that MakeCode uses. That's handling the connection, the pairing over your web USB. So your USB on your machine from the web page to your microbit. And then the rest of it is simply HTML, JavaScript, and CSS. So there's nothing, and all of this is open source. So, and you'll see that if you actually go on to our little web app, our bridge, everything is there to see. There's nothing server side. So really cool there. And then very quickly, before we open up for a few questions, what's next? Well, we definitely want to try this more. We want to get some feedback. And if it's if the results are positive, we'll continue developing it. But it's out there right now for anybody else who wants to try it. I think my email is there. So if you have some comments, you can easily contact me, or if you need some help. But in doing that, well, listen, we have, just like MakeCode, we have our microbit connected to a web page. And it was at that point I started realizing, well, there's another possible area of exploration here. And we've heard it quite a bit, and especially in this time, of COVID, the idea of, wouldn't it be cool if we could connect microbits all across the world with each other over the internet? So that's the next project I've been working on, using some of what I've learned in this bridge for Teachable Machine to microbit. Now looking at connecting microbits. Now basically think of the Internet of Things. So, you could have a microbit in a classroom right across the world that's taking the temperature every day or the light level, and that data can be streamed back to you in your classroom, and you can use that to do something with your microbit, or you can just use the data and look at it, and share that data all across the world. So that's where we're sort of going with it and exploring this technology. So it's quite exciting. And let's see. Before I open up for questions, I do have one example. Maybe I can share it with everybody, because I do love it when we get to a chance to do some hands-on. Let me see if this is going to work. We'll try it. So I'm going to put something in the message. And set this up. I'm going to stop the sharing. We need to see this. So this is a prototype. Now, I love old tech. So I wanted to connect a microbit, and some of you might recognize this. This is an old telegraph system. This is the receiver. Now, give me a sec. I'm just going to do a quick test. All right. So somebody's already opened the app, and you are operating this telegraph here, and you're doing it via a microbit and a digital or solid state relay. That's awesome. Honestly, I couldn't wait to do that. The chance to have people from all over the world operating this telegraph in my office is so cool. So you can see the potential there. Now, you don't have to be using a web page. You could have been using a microbit to do it.
Phil, is this the first time you've had it live?
The first time I've shared it outside of the company, yes.
Well, congratulations. That is incredible. Making some more microbit history here, everybody.
Yeah, and what a wonderful thing then to do it with history. This is an actual piece. It's probably about 1920, wow. And it was actually in use. So, yeah, how fantastic! And here's the kicker. The device I use with the microbit, the relay, which is basically just a switch to turn off and on the power, because it needs much more power than our microbit can supply. Well, the relay is actually like the great grandchild of the telegraph, because it's the same thing. It's a switch. When you hit the telegraph, you're opening and closing a switch. This is a mechanical relay. That's a solid state relay, which is much more responsive. Yeah. That's cool. Hey, wait, does somebody actually know Morse code?
I was going to ask what's being sent here. Is there a history? So do you know where this telegraph was in operation, Phil?
No, unfortunately not. I couldn't track down the original owner. I do like to try. This is one of my favorite hobbies, is taking old tech and connecting it to microbits. So this is one of the projects that I have. I have some old telecom machines and stuff like that I like connecting. But I think it's fantastic because when you look at old technology, sort of like brute force technology, right? But it's visible, it's huge, And it opens up another avenue of fantastic questions. How did we get from this to something this small? Right? It starts to make you think about that. But this, we can actually see it. We can actually understand and look at it and see how it's working. And then that makes us get curious about, well, how do we do it in solid state? So it's a great avenue for getting that curiosity going. And I tell you, I can do the same thing like this and just put a speaker here and have instead of the telegraph, I'm going to have a modern speaker playing a note. People are not engaged. As soon as I pull out the telegraph, suddenly everybody is like, okay, this is cool. And yet it's pretty much the same thing.
So I noticed that in the chat here, we had someone say we need to build a Morse code decoder. And maybe that's the next piece with the microbit, especially with V2 and its speaker that can decode it and speak the telegram that's been sent
exactly
over.
And one of the things you will discover, and some of you have probably already noticed this, is that it also introduced a new programming challenge here, a communication challenge, because we know that using the internet, you probably experience lag. So there's probably like hesitations or delays between each key stroke. Well, that wouldn't work with Morse code. Morse code is based on a tempo. There's dot dash, and it has to be at a particular speed. And if it doesn't happen, then the message is gobbledygook. So again, this is a really, let's say, basic way to look at these challenges. And you could code it. There's a way you could code it in make code so that you buffer it all and make sure that it plays back at the right speed. But again, a great way of introducing more modern problems like, well, how do we do that with Wi-Fi? How do we make sure that the Wi-Fi signal is the integrity of the Wi-Fi signal and whatever data is being transmitted? Because we know for the most part, data is pretty reliable. When you get your email, it's not like there's letters missing in the email. So how does it do that? Yeah, a lot of fun. So that's where I'm hoping to go. That's a real fun, and I really wanted to show some hands-on, but also the Teachable Machine thing, I think is really fantastic. Maybe we could teach the Teachable Machine to Morse code. So we talk to it and we teach it to recognize words, and then once it recognizes those words, translate it into the right Morse code, right dot dash dot. So there's all sorts of fun things we could explore.
Amazing. Phil, just kind of scrolling through the chat here, seeing if there's any other questions to surface for you here. There's just some big love and excitement for what you've shared around Teachable Machine and now this telegraph. So you've inspired. There's a lot of stuff over Microbit Live and in the Microbit community.
Oh, great.
I know I'm probably not speaking alone to say this. What you've shared has got me excited to even pull up the microbit and boot up the editor even this afternoon and play around with some of these projects.
Excellent.
Quickly for those who are joining, and just as a recap, what's the best place to find you online and to look at some of these projects again?
Okay, so at Kids Coding is the Twitter for Kids Code Jeunesse. I tend to stay off social media, but also here I'll give my email as well. Sorry, I sprained one of my fingers, so I'm a little bit slow at typing. There we go. And that, I believe that's correct. I'll just double check. Yep. So yeah, if you want to tweet out to Kids Coding and just put my name in it, I'm sure they're watching. Yeah, it's awesome. I have so many other projects. I'll just give you this little guy here is actually a theremin. It's a musical device with microbits. It actually detects the presence of my hand, and as I put my hand through it, it plays different musical notes. There's tons and tons of stuff we can do with the and let everybody know, this is all microbit version 1. It'll work with version 2, but if you have old microbits, good to go. Yeah.
Oh, that is such an encouragement as well.
Yeah.
Those around. Yes.
Yeah.
Awesome.
Love to come back. Well, thank you, everybody, and Thank you, Titus. It was a pleasure and an honor to be able to present today. It was really great.
Well, it's thank you. We really appreciated it, Bill. Excellent. Well, everyone, we do have a short break before we can pop back into our last session for Microbit Live. So I encourage you to pop back to the schedule and hear or find what you want to be inspired by next. Thank you all, and thank you, Phil.
Thank you. I'm sure I'm going to hear telegraphs all day.